Gravitational mass is proportional to gravitational. So just try to understand what is exactly this question trying to ask. Is there are basically two type of masses. One is known as an inertial mass, another one is known as gravitational mass. Gravitational mass means, suppose if you are considering mass m1 and m2, if they were separated by a distance r, we know that according to Newton's law there will be a force of attraction between them, which is g m1 m2 divided by r square. So the mass which is responsible for gravitational force of attraction, we call it as nothing but gravitational mass. At the same time, we can define one more mass which is known as nothing but the inertial mass. Inertial mass means, suppose if you are having an object of mass m over here, and if you are exerting some force f, it will accelerate with an acceleration a, which we can take it as f divided by m. So this mass over here is known as nothing but inertial mass, which is opposing the acceleration. We call it as nothing but inertial mass. And the mass which is responsible for gravitational force, we call it as nothing but gravitational mass. That's why we are writing this gravitational mass is directly proportional to gravitational force. And sometimes we may think that this intensity of gravitational field is gm divided by r square. So this intensity is also directly proportional to m. But in this question, they are not trying to ask in that sense. They are trying to ask in terms of gravitational mass and the inertial mass. Gravitational mass is proportional to gravitational force, like that. And this field, same thing over here. According to the equations, we may feel that it is directly proportional to m. But we are trying to talk about the gravitational or difference between gravitational force and gravitational mass and inertial mass. So inertial mass is directly gravitational mass is directly proportional to gravitational force.